So good morning, Saurabh. It's very nice having you here in our third session of Tech Talks 4.0 brought to you from AjnaLens. This is an initiative in which we are roping in people from computer vision and AI industry and having a semi-formal discussion in and around the topics which are of interest related to computer vision, AI, and different applications related to it. So I'm very happy to have Saurabh Pandey. He's leading the technological vertical in KritiKal. And KritiKal has been around since many years and doing some amazing work in computer vision and related services and ADAS and other intelligence. And so let's hear it from Saurabh Pandey. Saurabh, please tell us your early story.
Yeah, thank you for having me here, and great to be part of this initiative. Yeah.
Right. So can you hear about your early story? Like, how did you come into that field? How did you find interest in the field? How did you, start your journey in the industrial R&D related to CV and AI?
Right. So it's sort of, it's not chosen or something, but it goes back to my college days. I was doing my BTech from IIIT Hyderabad. And after completing computer science basic courses, we had to choose, we had an option to take some extra credits and complete the BTech course with honors degree. So we had mainly two choices. One is databases, and another one was the visual computing. So I think that started over there. We had looked at databases earlier, but visual computing sounded pretty intuitive. Like it's about, at that point in time, it was like given an image, extract data from it. And it's sort of very intuitive for human minds to extract information from images. So as I said, like 1,000 words for one image. So so I think that started over there, and having an idea to implement function of an eye in machines. So that was sort of interesting at that point in time. So so that basically led to me involving into this field.
Okay, so it was a very natural flow given the courses and you finding interest in the course. So I think this is very important for actually universities. I think right now many universities, unlike our time when we were in BTech, you were in IIIT Hyderabad while I was in IIIT Jabalpur. Not many courses related to CV and AI was just coming up at that time, but if we find, even I did my BTech project in image processing, and that is how I found interest in computer vision and image processing. So having the right resources right from the start in the your institute itself could be a blessing in finding your calling, right?
Yeah, it was. I was pretty lucky, I would say, in that sense, because there were pretty interesting projects and courses going on at that point in time.
I'm sure. So what has kept you in the same field when you joined your industry and you started working? What were the interesting projects that kept you going in the same field and finding, working on your skill set and, getting more and more expertise in the same field? You have been working in KritiKal for now, how many years? 10 plus years now?
Yeah.
So please tell us about some interesting projects you have been into and that have kept you in the same field.
Right. So this field is sort of full of very exciting, interesting projects involving processing of images to videos so this helps give us a holistic view of this area. So I started with some of the interesting problems of extracting. So this was related to automatically generating highlights from cricket videos, and then move to some of the medical related problems related to diabetic retinopathy in collaboration with one of the eye institute in Hyderabad. So there were different interesting problems. So when I started, it was not very like it was intuitive, but at the same point in time, for machines, it was sort of different problem. Like given a matrix, how do you extract information, useful information out of it? Human mind works based on like different cues, understanding things from context, from several cues. So it was sort of uh, uh, like set of challenges that had to be solved and worked on. Then also like in KritiKal, like been part of different types of projects from different domains. So you mentioned ADAS. There was so visual computing plays a very crucial role over there. So some of the things like automotive braking systems to adaptive cruise control systems. So some of these problem requires very high accurate vision computing
Right.
mechanism. And these are so these type of and then there were problems related to SLAM, then number plate recognition system. So like different problems coming from pattern recognition to image processing to robotics at some point in time. So yeah, it has been like very different, diverse set of areas.
Right, right. So you have touched upon a lot of applications, and I really want to highlight the points for our young viewers. And because to attract youngsters in the field, they need to know what are the applications of CV and AI. Otherwise, it might just look, a lot of algorithms and big names, neural networks, and GANs and but what are the application areas when it comes to CV and AI? And you touched upon subjects like medical imaging and even lots of information. People do not realize when they're viewing cricket how it has evolved over the decades, and the information when they view so much CV and AI goes into it. And that is all very interesting to youngsters, and I hope they read more and more about the application areas, about ADAS, autonomous, advanced driving assistance systems, and robotics. How computer vision is so inherent to robotics and perception for robotics. So, so your versatile projects could be a cue for them to join the industry and garner more experience. So, what do you think are the prominent problems that one normally faces in CV and AI, especially when in context to industrial work experience, not in academia? Because academia is still, when we start out it is a lot to do with MATLAB prototyping and a lot of things already there in the library and just applying and, just seeing on the data that is available or models that are available. But, problems that one faces as a developer when one joins a company and is actually solving a real world problem.
Right. Yeah, so that changes a lot. And in industry, it's important to be able to solve problems which are useful for end users, and that sort of requires a systems view rather than just focusing on one part of the system. Correct. So when I say system, so it includes sensors, then what type of algorithms would you use to process data coming from those sensors? Correct. And then what type of environment will you deploy these algorithms or interface them to be able to meet the end KPIs or the performance? Correct. So and all of these dimensions have their own challenges. If you talk about sensors, so there are different nuts and bolts to be fine-tuned. If you talk about camera, so it starts with sensors itself, CMOS, CCD, then lens properties, what type of lighting would you use to be able to illuminate scene. So that itself sometimes changes with respect to what particular thing that you would like to measure, because some of the objects have different spectral sensitivity. So there is lots of scope of having proper illumination for that. And then there are different configurations of camera itself which can be fine-tuned. Now things like shutter speed to exposure, etc. Now, on the algorithm side, if you see, there are different types of algorithms now coming from geometrical computer vision to traditional machine learning based system to neural networks. And then on the compute side as well, there is a whole spectrum of compute platform available from edge to cloud. With different properties. So all these dimensions needs to be taken care while we are working in industry. And some of these problems are sort of, sometimes it helps optimizing and working on fine-tuning on some of these areas to be able to meet end users' requirement.
Correct.
So yeah, I think that's where we write our assumptions, and sometimes we make changes to those assumptions to innovate. So industry, there is a lot of focus on that aspect.
Very true, very true, and that applies across all industries which are in this field. And as you rightly said, having a system or a systems view rather than jumping into the nitty-gritty of implementation of any particular algorithm is very important for all the developers who are working in industry to solve any given problem. You have to understand the problem, break down the problem, and then see a lot of hardware and conditions, what kind of data you're playing with. So all of that is really important. So jumping into the algorithms directly, something that is fancy and is in trend right now, might not be the best solution. So planning it out is really important. So what do you think, Saurabh, are the major misconceptions you feel that you see in a lot of, youngsters, or even in, even in bigger industries who are, big players in this field? What do you think are the major misconceptions in and around computer vision and AI for freshers, maybe for youngsters?
I would say, since this is a trending field, there are lots of new opportunities which are opening up, lots of use cases that has potential to be solved. But I would say we need to take, like when we are solving or we are taking up a project and trying to apply, let's say, computer vision and AI techniques on those. So some of those things needs to be done in a systematic way. So it's not a silver bullet just to, like, we can apply this thing on everything. So on the student side, I think, or let's say somebody who is starting it, working in this area. So they start with, let's say, some of the common things that they think about, that it requires lots of data or very high compute, let's say, or lots of maths upfront. To some extent, it's true, but I think not always. There are good abstractions now available in the form of neural network based approaches, which can be utilized to be able to solve these problems. So I think there are specific things like how we can utilize, which area we can target for AI based solutions, and as well how do we target those? How do we approach those problems? Do we need all the data, or in what modality, or so all these things are something which we have to, like, we should keep in mind while we are targeting.
Correct, very true. So we have also seen that people come with the mindset that, if they are solving a problem and they know a certain algorithm, then we should just provide them with lots and lots of data to start with, and lots of compute to start with, and that should be a piece of cake then. But having that kind of data and having that kind of compute might not always be possible. Specifically, it is around the client requirement. And I've seen there is a lack of understanding for a lot of, freshers in deploying the, models and deploying their algorithms on resource constrained platforms. A lot of the courses do tell us how to, engineer the data and how to train your models, but not how to optimize them and how to finally deploy them. And that is where the skills, are lacking, because as a developer, I think it is very important that you should know from the start to the end how to deploy. At least in a team, you need to have the idea to finally deploy it and make it into a product. So learning optimizing skills and learning skills to finally deploy, that are very important. Those are very important to the industry, right? Very much
the
so.
Platform. Yeah.
Correct. Yeah. You were saying something, Saurabh?
Yes. So, like as you said, some of these like off-the-shelf model doesn't scale well for the problem. So,
exactly.
So those needs to be adapted for, and sometime those data are not available upfront for the use case. How do we make sure that those are adapted for the domain from starting? How do we use simulation data set, or so these aspects are sort of important, becomes important when you're working on client projects.
And choosing the right algorithm, I think that is also very important. I mean, I've seen people just running towards any new neural network to solve any given problem that might not be. Even as you said, the traditional CV approaches, geometrical approaches, at certain points of time, they might be just enough. We might not want 99.99% accuracy for all problems. We might be more interested in real-time application. So for that, like as you said, SLAM. Now there is SLAMs. There are so many variations of SLAMs, and for most of the use cases, I think the traditional geometrical features based SLAM is just enough. With good sensor fusion, that should just be enough, and no need to jump for neural network and learning based techniques there. So finding the right algorithm, understanding the problem, I think, is
understanding the problem and having a spectrum of like what all things are available.
Correct.
How we can
literature survey.
What are the pros and cons of those? So things like what type of sensors itself. You mentioned sensor fusion. So which sensor has what properties and where they can be utilized.
Right.
I think that helps down the line while delivering the project. So
exactly. So coming to this, actually, when you talk about sensors, and this is how where I think you can elaborate about academia research versus commercial research when it comes to CV and AI, because coming from good institutes, we might have access to some very nice sensors, some great compute. We might have lidars for our ADAS and autonomous, navigation for our drones, whatnot. But when it comes to solving it for a client, solving certain we might have to consider a lot of things. Cost becomes a big factor. So likewise, what do you think, what separates academia research and the commercial research?
Right. I think both of them are trying to solve different part of the problem. I guess academic research are sort of trying to move the needle towards making greater state of the art for like finding new ways to solve problems. Um, Whereas in the commercial research or industry-led research, so there it's like how do we really make sure that the solution that we are providing adds value to the end users, not necessarily, let's say, devising a new algorithm or let's say uh, a new mathematical formula, uh, but it's about like using one which works for a given problem. Um, in critical, we have this terminology so all of these is research and development. So we call it so R&D. So academic research focuses on capital R, small d, focused more on research and in critical we say small r, capital D. So it's basically trying to bridge the gap and collaborate together. Um, I think it's important to look at, let's say, what end users need and the constraint for a particular problem, and to be able to utilize best component which is available from the tool set. I think in the recent past, there is lots of progress happening towards making it real world, like uh, uh, applying these research in real world problem with industry-led research, I would say,
Right.
to start with, let's say, availability of lots of data in ADAS domain itself. There are data set now which is available with different types of sensors combined, which helps in terms of people getting a feel of what the end user or what the end problem would look like. Um, but having let's say a holistic view of the problem, be aware of different types of design choices which are available and choosing the one which really helps solve the problem in the constrained environment. I think that helps in the industrial set.
Correct, correct. And specifically in CV and AI, I think people who are working in the core CV and AI solutions, they work closely with hardware. So we make our own products as well, hardware, and we
Yeah.
also create solutions on top of the hardware. So having a systems view and then all the constraints regarding, we cannot go with adding all the sensors there, heat dissipation, cost, all become
Right.
very important design choices, and that affect then the software choices. So all of these plannings in the are very very critical to industrial small r and capital D.
Right. Yeah. Having combined understanding of hardware and software. So like hardware based projects like which you are particularly involved in. I think that's something which is increases the complexity.
Right.
I would say, because then you have to finalize the hardware, and then based on uh, software needs to work with that hardware, and if there are any mistakes in the hardware, that goes the cycle of correcting that becomes higher. um, yeah, so I think some of the research in this area where we design hardware and software combined with keeping the constraint of each other in mind, I think that's something very interesting.
I would like to share a small thing that happened with me just last week. So we had a very, bright young intern in our team, and we had given a problem of, depth estimation to him. And the idea was that we would probably use it for different applications, but specifically for a headset which is very lightweight and uh, comparatively inexpensive and might go for education purposes. So we said try and look for monocular depth estimation techniques that is in vogue, and a lot of research is going on. And he came up that a lot of them are not very accurate. Why don't we have a TOF sensor on board? Now that is and there are so interesting and so many papers, and you can do this and this. Very excited in turn. But I had to actually tell him that you do not go around changing the hardware, because the
Yeah.
headset is already made, and
Right.
because of certain constraints, that headset was made the way it was. We have different headsets with different sensors, and that might be on the higher end, but for this lower end, because of heat dissipation, form factor, cost, we do not end up adding too many sensors on the headset. It might be an overkill.
Right.
So given the hardware, you have to find the algorithm, you have to
Right.
find the
Right.
software given the problem statement. So that is something that came to my mind when you have to make the choices.
Right. Right. And yeah, I think that's absolutely correct.
Right.
We have to adapt our and choose the software with suits the hardware.
Correct. So going to the progress that has been made in CV and AI, what can you your opinion on what is the future in the CV and AI? We already know there are so many applications that are coming up. What are the interesting AI applications that you see happening in the future, and that might interest the youngsters to learn more and more about this field?
Right. So, like computer vision and AI are opening a lot of use cases uh, from different domains, be it at education sector to augmented reality to virtual reality uh, to healthcare and I think with the help of neural network based techniques, I think some of these things have improved a lot. So we have a good abstraction, uh, and which helps now we can utilize these technologies for some of the hard problems that we have. So if you look at ADAS, where many companies have zero fatality on the road as a target. And I think some of the advancements of these will really help in this area. If you look at healthcare, so now people would be they will start using their smartphones to be able to, let's say, diagnose some of the early signs of a problem in their homes. Uh, then, if you look at, let's say, augmented reality, so there are lots of in our times, learning was sort of not that convenient, but with these help of these technologies, I think we get like lots more visualization and lot of uh, things which are available at the hand to be able to really learn and make uh, really comprehend, I would say, rather than just looking at it. So I think some of these techniques are really helping here. But I feel there are few things which are still to be solved. So things like how how we can make the learning, so deep neural network learning itself faster. So can we utilize active learning paradigm where machine itself, rather than giving lots of data to it and lots of compute to it, can
Learning
machine
on the
be able
go.
to, yeah, may be able to find the hard images or area where it's not working well, and it's able to actively seek help from active learning framework. So some of these areas I think are still work in progress and exciting field where some of the youngsters who are coming into the field can contribute and uh, make the state of the art further.
Amazing, amazing. I agree there, and already there are some systems in place, but not they have not been adopted so in the mainstream by many companies
Yeah.
yet, because as you said, they are still work in progress. So having problems like asking the customer to send back data so that we can improve the system is not always feasible. So
Yeah.
and you might learning like classifying one kind of object, you can give a model for that, but what if the client wants to have multiple products on the go, then you have to retrain, get more data. So having such kind of this is just one example, but even just accuracy, learning from the mistakes and reinforcement learning in a way is really
Right.
important, and
Right.
that is where the future
Yeah,
is heading.
and the potential for this field is like because it's driven by human mind, and the
Mm,
benchmark is that.
correct.
So like it's very intuitive to say, why don't you, let's say, detect this? It's visible, right? But for a machine to, so there are lots of places where machine could go wrong. But yeah, so the expectations are high, and there is lots of scope to improve the system and algorithm to
Right.
meet that expectations.
Correct. Right. So, having discussed the future and of CV and AI and what is in bags for people, what are the few tips that you can give to students and freshers who are just starting or want to join this, CV and AI field? What are the few tips that you can give that might help them, join the field of CV and AI for some industry related problem solving?
I would say that to keep a top-down based approach rather than, let's say, uh, first trying to, let's say, cover all the aspects of it in terms of theory, and then looking at the problem. So rather than that, maybe start with some of the interesting problems, and then figure out how what all things that goes into the into solving those.
Right.
So nowadays there are lots of resources which are available on net now, with many courses available, with lots of tools available to be able to get started. Um, so I would recommend for someone who is starting it to look at those, pick up some of the problems that they find very interesting, get get their hands dirty to start with, like try to build those system and see where are the bottlenecks, what is the accuracy that's coming up, what are the constraints. So and then iterate on that, set up set up in baseline and then iterate on that. uh, Having a top down approach, I think that will be helpful for them to understand the complexity of the entire system, uh, understand the limitations and the constraints that one can work with, and where the current approach or the current system stands, so that they can basically and they would know what is the levers that they can pull,
Mm.
what are things that they can work on to further improve it, rather
Right.
than going into the fields of, let's say, maths. Let me understand all the maths behind it, or let's say let me understand all the algorithms from classical pattern recognition to machine learning to whatnot. So rather than doing that, jump to the problem and then uh, take it from
Very interesting idea. I think that would really help, given that focus is really time, and capturing the
there.
focus of youngsters itself is very important for them to learn anything, and that can only be done if they jump into solving a real world problem rather than learning theoretical algorithms, all the algorithms that are there in the market. So learning backwards from the problem to the algorithm might be the key. So very interesting, right? So coming to some very interesting topics of discussion of AI, which are, doing rounds in, 2020 and 2021 as well, about, and lots of giants are now like held responsible about this, is data privacy. Now, people do not really understand the significance of data privacy when it comes to AI, and how it is both a, you cannot really run from it. You cannot ask for the evolution of AI to stop because data is jeopardized. But what are the measures that people are taking? Why is it important? How it could actually garner, more and more opportunities rather than being the evil that it is depicted as, but how it could be actually an opportunity for people. So, what are your thoughts on data privacy?
That's interesting subject, I would say, and still, I would say, as a mainstream world, we are trying to have a baseline system that works in real world. But at the same time, I think data privacy is one of the concern, and people are sort of now being aware of it. But I think there is lots of to be done in that aspects, especially like country like India, where the I would say we don't have the baseline system as of now available with us. If you look at ADAS, and if you look at Indian scenario, so that sort of that makes it very hard to be able to run that system in Indian scenario. But having said that, data privacy is something which is very important. There have been scenarios in past where utilization of data itself is being intensified, or some of the system, like while we are designing, so that's at that specification itself, there is a requirement that it should be privacy aware system, helping, like having systems like edge computing, etc., helping in that domain. Like there is no need of storage of, like, transmission of data to a server and then storing it, and then let's say utilizing in different parts. So some of those things are helping, but we, like, as a society and in the industry, we should be aware of this problem, that what data that we are using and how we are using it, and making sure that it's sort of not, let's say, that is used for the purpose. So one of the problems that we were solving like few months back, was we were creating a sort of working on a system which stores images, but since those images were coming from users, so it's not we were having filters. So we were trying to make that system privacy aware, or we were filtering out images, videos which are not relevant for the system by having some models. And then, so I think there is a need of being aware of this problem and taking proactive decisions in terms of having a requirement per se. There are guidelines also available now which can be followed. So yeah, it's an interesting time where we are trying to have a baseline system, as well as trying to sort of not violate some of these requirements.
Right. Very true. Having the, taking proactive decisions while planning and designing the system itself, and some of the solutions that you said, having, like, using the data on the edge if it suffices not to store the data on servers or anywhere else. And those are a few ways in which you can actually ensure the privacy of data for your clients. And of course, this question will remain, burning. Big companies in US have, many places they have almost taken a vow not to, use data like face recognition and your personal data, not to use it at all. And but then there are countries who have actually used this data on the very large scale to actually do surveillance, crowd surveillance, and actually curb down the expansion of the pandemic COVID-19, and actually have used it in a very good way. So there you have a discussion whether to use the data, whether not to use the data, to what extent use the data. That kind of concerns will always be there, but it could always be an opportunity, because companies who are expanding in this field and are actually going to collect data can also have more and more people in the who are actually ensuring the privacy of data, and also funding researchers how to ensure privacy of data, how to encrypt the data, how to, like as you said in one of the case studies that you, likewise we also have a case study in augmented reality in which we map the surroundings of a place, but then we have ensured that that map can actually not be used outside that location. So when you come back to that place, it recognizes the features, it loads the saved map of that place, but you cannot actually load that map outside that place somewhere else and use see how the office looks or how your surroundings look. So that way, at the planning stage itself, some of the interesting and innovative ideas can be implemented to ensure to some level your data privacy. So that could again be another topic of research for many students and freshers.
Yeah, very exciting topic where privacy aware systems and how do we basically localize data, as you mentioned, like when we can use something at one particular place itself.
Right.
So yeah, there is exciting opportunities and research area of research which is available.
And all of this is only, we are discussing this only because we are thinking not just about the what we can get from AI, but also how to impart that ethical training to the AI, because AI is something that we train. That is, and I think with the evolution of AI, what is happening is, as you rightly said a few minutes back, that the benchmark is human mind, right? And we are trying to emulate the perception and the context understanding that a human mind has, that we are trying to impart to AI. And that's why a lot of discussion happens around how to make it ethical understanding. So ethics around AI have been a very interesting topic of discussion. So what are your thoughts on ethical AI?
Right. Yeah. So that's also something which is something like important aspect which to be kept in mind once while we are trying to solve problems for users. So some of the things like how do we basically utilize, or how do we avoid biases, how do we so there are inherent biases which are available in the system, how AI can basically help eliminate those. And then things like, so now we are sort of targeting for, let's say, bigger role, which is artificial general intelligence and making next level of artificial intelligence in that domain. So having these components like privacy, ethics, biases, all these factors become important, because then basically you don't want to, like, the benchmark is to be able to meet human intelligence. I remember a movie which is I think I forgot the name. I think the Dhamal movie, when a person was on a plane and the pilot pilot was not in senses, and he had to land the plane. Now he called the ATS, and then it was locked. The conversation was something which is a person is talking to a machine rather than an intelligent system. So benchmark is to basically now system should be able to understand what is the emotions of the context. So be it visual in computer vision, or be it like a conversation chatbot, or um, um, so all these systems where a human is interacting with machine. So all these aspects, how uh, do we understand what is overall context of the system, and how do we respond to that? So all these components will actually become important when we are designing, let's say, next level of intelligent systems overall.
Right. Very true. And I think because we are emulating and trying to emulate human mind, I think with the evolution of AI, what we are able to achieve is a better understanding of ourselves, of how we perceive things, how we, even philosophical questions are being asked. How do we find what is right and wrong? And a lot of research goes into it, actually, with the advancements in neural networks, and a lot of psychology, related to human mind itself is actually developing, and all of it is to impart that kind of ethical understanding. And uh, because when we will understand how our mind works, how do we think between right and wrong, only then can we train our system to think the same way. And as you said, having an unbiased system is something that is a goal for many companies, and difficult to achieve, but yes, again, an opportunity.
Definitely an opportunity to look into, and eventually those factor will come into picture as we have robust solutions for these problem. I think there will be focus on that more so going forward. I think there are research already available which tries to figure out these drifts and biases in the system, but they will start becoming more mainstream with the new research.
Great.
Exciting area
as you said. Yeah, so I think this brings us to the end of our discussion. It was very interesting talking to you, Saurabh, on all these, very traditional CV AI techniques to what lies ahead in the future, and your tips and insights for freshers are really, I think, very useful to them, would be useful to them. And any closing remarks that you might have?
Yeah, hope that helps. And I would say we are at very exciting time where lots of things are getting expedited with the new every day new. If you look at number of research paper which is being published, so that's growing exponentially in this area, and we basically see a very bright or exciting times. I would say going ahead. Looking forward to that.
Right. We find ourselves at the beginning of the conversation when we said, how did we come into this area? For you, it was a course that you chose, and for me, it was a BTech project topic that I chose, and I think that started us on a very exciting journey. And I hope other students also find their calling in this field, because there lies a lot of more work and development to, and will not reach saturation anywhere near future. So
absolutely.
So thank you so much, Saurabh, for joining us on this enlightening discussion, and we hope to have many more discussions with you and other people in your company, and I hope this was interesting for you as well.
Yeah, thank you, Yukti, for inviting me. Absolutely fun having at this session. Thanks a lot.
Thank you. Bye-bye and take care.
Bye. Take care.